In this video and in subsequent videos, we'll be looking at basic mathematics. In this particular one, we'll be looking at the multiplication of whole numbers, and I'll be showing you why we do some of the things that we do in the performance of these operations. First, let's look at what I have here. Powers of 10. 10 to the 0, of course, is 1. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000, and so on. 10 to the negative 1 is 1 over 10. These are the ideas dealing with negative exponents. 10 to the negative 2 is 1 over 100. 10 to the negative 3 is 1 over 1,000. 10 to the negative 4 is 1 over 10,000. And of course, we in our number system, we deal with base 10. So our digits go from 0 to 9. So I want to point out to you first that when I write any whole number, say like 237, it's always understood that a decimal is to the far right. So in this case, if I'm looking at the whole number 237, I can actually think of that as 237 point decimal. Okay. In some cases, we're dealing to decimal numbers. We'll have values over here. So we have a decimal, and then we have place value right here, 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 and so on. So this will be the ones place. So that'll be represented by, say, 10 to the 0. That's 1. This will be the tens place. That'll be 10 to the 1. And this will be the hundreds place, 10 to the second. Then we have the thousands place, 10 to the third, and so forth. And every one of these entries will be multiplied by a digit from 0 to 9. Okay. And then on the right of the decimal, we'll have the tenths place. This will be 10 to the negative 1. In this case, we'll be dealing strictly with whole numbers, so we won't be dealing in this area at this point. Then we have the hundreds, negative 2. And then we have the thousands, 10 to the negative 3. And so on. Okay. So because we deal with base 10, every number, whole number, can be written as a linear combination of terms involving powers of 10. Well, before I get into that, let me go ahead and also give you a few basic laws of exponents. When you're multiplying powers of the same base, in this case, we'll be dealing with base 10. We add the exponents. So if I have, say, 10 to the second times 10 to the third, I bring down the base and add the exponents. So that'll be 2 and 3 is 5. Okay. In the same way, if I'm dividing powers of the same base, I subtract the exponents. So if I have, say, 10 to the fifth divided by 10 to the second, I bring down the base, in this case 10. It could be any other number, but in this case we're dealing with base 10. I subtract the exponents. 5 subtract 2 will give me 10 to the third. Okay. So we'll be using those in this video and in subsequent videos. We clear this. Now, as I said, any number can be written as a linear combination of terms involving powers of 10. So 438 can be written in expanded form like this. Okay. So again, 8 is in the ones place, 3 is in the tens place, 4 is in the hundreds place, so that's why I can write it this way. So 8 times 10 to the 0, here 10 to the 0 is 1. And then 3 times 10 is 30. 4 times 10 squared, that's 400. So it's 400 plus 30 plus 8 is equals 438. 34, okay. 4 is in the ones place, so that'll be 4 times 1, or 10 to the 0. And 3 is in the tens place, so that'll be 3 times 10, so it'll be 30, and 4 is 34. Okay. So even though we have it in expanded form, when we add these, okay, basically line them up. So notice it's 438, so I have the 4 under the 8, that's the ones, and the 3 under the 3 in the tens place. And well, then we just add. We say 8 and 4. Okay, so if I look at it over here, it's 8 and 4, so it's got to be 12. 12, 10 to the 0. So I put the 2 there in the ones place. And because it's a 12, I have 110, so I carry that over to this place. Okay, and then I say, okay, 3, and now this is now the tens place here. So it's 3 tens and 3 tens, and of course the 110 that I brought over from this one is 7. And then this one I just bring it down. Okay, so that's addition of whole numbers, very basic. Okay, so we line it up, and we add like terms with the like terms. Okay, just like in basic algebra, you add x and x, y and y, and so forth. Okay, so that's the addition. Now, if I'm multiplying, okay, look at the expanded form over here. I would just multiply this 4, 10 to the 0. Think of that as 4, 10 to the 0 is 1. So it'd be this times this, this times this, this times this. Okay, and we put it down, and then we go this times this, this times this, this times this. Okay, and we complete the multiplication. Okay, so the way this is normally done, you see it over here. Okay, so I have 4 times 8. 4 times 8 is 32. Okay, but 32 has 3 tens and 2 ones. Okay, so the digits in these locations have to be from 0 to 1, so I can't put a 32 here. Okay, so since that's the ones place, I put the 2 there, and I carry over the 3 to this one. Okay, so I want these to be in the same format. So 4 times 3, so now here 4 is in the ones place and 3 is in the tens place, so 4 times 3 is 12, but because that's a 10, that's 120. Okay, so this comes 4 times 3 is 12, and then 3 more, so it's 120. You look at that, it's 120. If I just look at the 4 times 3, and then I'm adding 3, but remember that was 30. So if I add these up, that's 150. Okay, so now I want to keep it in relation to what I've started. So this is the tens place, so I can take this part of it right there, and that's 5 tenths. So that's why I put the 5 right here, and then I have 100, and that goes over to the next place over here. Okay, so that's 100. Okay, so that's now 4 times 4. 4 is in the ones place, but it's 4 times 4. That's 16. Remember, 4 is in the hundreds place, so that's 1600. But I brought over 100, so that becomes a 1700. 1700. Okay, so the 1700, I can put a 7 here, and that's in the hundreds place. Okay, and then the 1000 goes over to the next place, okay, which in this case would just be a 0 there. So if I bring in the 1, bring it down, I get 1752. Okay, and that's how I get this first row right here, 1752. And normally when you do this, you're doing it without thinking, okay? When you do this, you go 4 times 8 is 32, and you bring over the 3, and then you say 4 times 3 is 12, and 3 is 15. You're not even thinking of whether you're adding hundreds or thousands or tens, but that's what you're doing, okay? So we clear this out. Okay, so now we're going to multiply by the 3. Now 3 is in the tens place for this one, and we'll multiply 3 times 8. That's the ones place, so that's going to be the tens place. So that's why we move this over one place. Now this had been 3 digits, we'd have another row over here, and that would move over here to this side. Okay, so I go 3 times 8. 3 times 8, that's 24. Okay. Remember, this is the tens here, so that's actually 240. 240. Okay. So the 40 can be written as 4 right here in the fourth in the tens place, so that goes there. And then the 2, that's 200, so that has to go over to the next place, which is over here. Or here. Okay. So 3 times 3. Okay, now we're multiplying tens with tens here. Okay, so that's 3 times 3 is 9, but it's actually 30 and 30. So that's 900. Okay, and then I brought over 200. So that's 1100. Okay. So now break this up. This is 100, and then that leaves you with 1,000. So I put the 1 right here, because that's the hundreds place right here, and then the 1,000 goes over. So that's 3 times 4. 3 times 4 is 12. 3 times 4 is 12. And remember, this is tens and this is hundreds. So that's actually 12,000. And then I'm bringing 1,000 over. So that makes it 13,000. Okay, so the 3 would stay right here, and then the 10,000 would go over to the next one. Okay, so that's just bringing it down, because this would be just, if you want to fill it in with zeros here, you could. Okay, and we get this one here. Now everything is set. Well, now I have ones, I have tens, I have hundreds, I have thousands here, and I have 10,000, so I just add them up. So 2 and 0 is 2, 5 and 4 is 9, 7 and 1 is 8, 1 and 3 is 4, and of course 0 and 1 is 1. Now again, if this were say a 5 here, then I would have to carry over like I did over here in the addition. Okay, but that is why we do what we do when we multiply. So when like I said, when you're actually doing this, you don't think about it. 4 times 8 is 32, and we bring the 3 over. 4 times 3 is 12, we get 15. Okay, and then the 1 comes over. 4 times 4 is 16, we get the 1, we get 17. Okay, so it's important to know that. When I was helping my granddaughter out, and she was doing this with, say, addition or basic multiplication, she knew how to do the carrying like this, but she didn't really understand why we were doing this. She was just mimicking what the teacher told her. So it's important that you know why it is, or why you do what you do when you perform these operations. So that's what I'm trying to accomplish in this video. So I hope that was clear. I'll have some other videos coming up on multiplication of decimals, division, and so forth. Now, the other thing I want to point out in the multiplication, I'll be using that in the next video also. Basic facts, if I have, say, 35 times 10, most of you know the shortcut to this, but if I do it the long way and say, okay, 0 times 5 is 0, 0 times 3 is 0, no problem there, and then I go over again because the same reason 1 times 5 is 5, 1 times 3 is 3, and then I follow through, everything is lined up in the form that we wanted, we get 350. Okay. If I have 35 times 100, or 10 squared, if I do the same sort of thing, I come up with 3,500. So we have the basic fact then that we derive from this, that if you're multiplying any number by power of 10, okay, 10 to the 1, 10 to the second, 10 to the third, 10 to the fourth, or whatever it is, we simply write the number out and then just add the zeros on the right, right? Multiply by 10, we add 1 0. Multiply by 100, or 10 squared, we add 2 zeros. Multiply by 1,000, or 10 to the third, we add 3 zeros. And so forth. Okay, so basic facts. And we'll see you in the next video. Thanks for watching.